Hello everyone, I'm Yazan Ibrahim, or as some of you might know me, Yazan Abu Ghosh. Today we're going to dive into a fascinating and essential topic from Chapter 5, Protection of Information, Assets. Part A, Information, Asset Security and Control. 5.10, Virtualized Environments. If you are a seasoned auditor, or just curious to understand how information systems into business environments, you've come to the right place. Let's begin. Virtualized environments, an in-depth exploration. Let's start by imagining a bustling data center filled with humming server racks. Each server traditionally represents a single physical machine pressed into service to handle its specific tasks. This setup, while reliable, often leaves vast portions of a server's processing capability unused, wasting energy, space, and operational potential. Enter virtualization, a revolutionary solution that transforms the way organizations interact with computing resources. It's not just a shift in technology, it's a paradigm change designed to increase efficiency, cut costs, and provide flexibility. But as with any innovation, it introduces challenges and risks that must be managed carefully. The foundation of virtualization. At its core, virtualization is the art of creating multiple virtual systems that coexist independently on a single physical machine. Imagine a powerful host server splitting itself into several isolated environments, each running its own operating system, OS, as if it were a distinct entity. This is made possible by a clever intermediary software layer called the hypervisor. Think of the hypervisor as a sophisticated traffic cop, orchestrating how CPU power, memory, and disk storage get efficiently shared among all these virtual systems, often referred to as guests. This idea opens up incredible possibilities. With virtualization, organizations can abstract the underlying hardware and combine resources, like CPUs, memory, disks, and even networking, into shared pools. These virtualized resources feel real to the systems and applications running on them, but with the added benefit of flexibility and scalability. Need to add more computing power, allocate resources without procuring additional hardware. Want to test applications in different environments? Spin up isolated virtual machines, VMs, with a few clicks. Why virtualization? The benefits of virtualization are numerous, and they span a wide variety of use cases. Let's break it down. 1. Operational efficiency. Instead of letting hardware sit idle, virtualization drives each physical server to work harder, hosting multiple guest OSs and squeezing more value out of every machine. It's like upgrading a two-lane country road into a busy multi-lane highway. 2. Desktop virtualization. Imagine employees needing applications that rely on various operating systems, all on one workstation. With desktop virtualization, a user can seamlessly run multiple OS-dependent applications as if they were native to their machine. 3. Security and management. Virtualized environments allow organizations to better secure and manage their systems. For example, by maintaining controlled, isolated OS images, IT teams can respond immediately to emerging cybersecurity threats by rolling out updated images across their systems. 4. Business continuity. Hosting virtual machines in geographically diverse locations allows organizations to create duplicate systems for disaster recovery. This way, operations can continue even if one data center faces an outage. 5. Cost savings and scalability. Virtualization reduces the need for expansive server infrastructure. With fewer machines to buy, power, and cool, the total cost of ownership plummets. Adding new resources becomes flexible. Virtual environments can grow or shrink with ease as needs change. Types of virtualized architectures. While virtualization sounds straightforward, the specifics of implementation can vary depending on the kind of architecture used. Let's explore the three main options. 1. Bare metal, native. Virtualization. Picture a hypervisor running directly on the host hardware, bypassing any reliance on an underlying operating system. This bare metal setup achieves maximum performance and isolation by operating close to the hardware. It's often favored for high-performance workloads and enterprise-grade systems. 2. Hosted virtualization. In this approach, the hypervisor operates on top of an existing OS, such as Windows or Linux. While useful for desktops or smaller setups, this introduces an extra layer of complexity. Performance can suffer since the hypervisor must coordinate via the host OS, but it offers the convenience of managing virtual machines through familiar user interfaces. 3. Containerization. Here's where things get even more specialized. Unlike traditional virtualization, where each environment includes its own OS, Containerization allows applications to share the underlying kernel but run in isolated processes. These containers house everything an application needs, its dependencies, configurations, and libraries, but with minimal overhead. A prime example of this approach is Docker, which powers much of the modern cloud-native application world. A balancing act, virtualization's advantages and risks. While virtualization promises flexibility and efficiency, it carries inherent risks that must be addressed proactively. Let's examine both sides of the coin. Advantages. Cost savings. By consolidating workloads, server hardware costs drop dramatically. There's less to maintain, and idle resources finally get used effectively. Space efficiency. The physical footprint of servers in a data center shrinks significantly, freeing up resources for new uses. Testing and training. Developers and educators can run multiple operating systems on one machine, enabling affordable experimentation and learning. Disaster recovery. Virtualization makes it easy to replicate systems for redundancy, ensuring rapid recovery in the event of a failure. Risks. However, the same flexibility that makes virtualization attractive can also expose vulnerabilities. Single point of failure. The host server becomes a critical component. If compromised or disabled, all guest environments suffer simultaneous downtime. Misconfigurations. A poorly configured hypervisor or management console can become a gateway for attackers to access guest systems. Management console, security, unauthorized access to the console, which governs the virtual environment, opens the door for widespread control over all hosted guests. Addressing the risks, essential best practices. The good news is that many of the principles we use to secure traditional IT systems apply equally to virtualized environments. Here are some best practices to consider. 1. Lockdown access. The host and management consoles represent the highest value targets. Strong physical and logical access controls, including multi-factor authentication, should be non-negotiable. 2. Configuration management. Just as a physical server benefits from hardening, disabling unnecessary services, applying patches, etc., virtual machines and hypervisors need tailored configurations to minimize their attack surface. 3. Segregate networks. Virtual machines in highly sensitive environments, like a DMZ, demilitarized zone, must be isolated. All management traffic should traverse dedicated encrypted channels to minimize the risk of interception. 4. Monitor and inspect. Continuous monitoring for indicators of compromise is critical. This includes file integrity checks for the hypervisor, monitoring OS memory for unauthorized changes, and analyzing inter-VM communication for suspicious patterns. 5. Disable unnecessary features. Anything that facilitates unnecessary interaction between guest machines or the host, for example, clipboard sharing, unsecure guest tools, should be disabled unless explicitly required. Key risks in focus. Despite these safeguards, there are unique vulnerabilities that require constant vigilance. For instance, hypervisor. Rootkits, sophisticated attackers might exploit vulnerabilities in the hypervisor to gain control over all guest machines. Data leaks between guests. Memory leakage could allow one VM to access sensitive data residing in another. Snapshot risks. Often created for backup or testing, a snapshot can inadvertently store sensitive information, including passwords or encryption keys. The bigger picture virtualization doesn't fundamentally change the nature of IT risks. Any vulnerability present in a physical system will likely persist in a virtual one. But it introduces new attack vectors and operational considerations that demand careful planning and robust protection. By combining strong security practices with an in-depth understanding of this technology, organizations can unlock virtualization's full potential while mitigating its downsides. In short, virtualization is far more than just a technical tool, it's a strategic enabler. And when done right, it reshapes what's possible in modern IT operations, paving the way for a future that's smarter, more efficient, and remarkably adaptive. Thank you for watching, and as always, continue learning, stay curious, and we'll see you next video.